Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why your brain can feel so unique, like no one else sees the world exactly the way you do? Well, today we're diving into some super cool science that explores just that, looking at how we can map out the individual brain. Think about it. For years, scientists looked at brains sort of like a big average. They'd take lots of brain scans from different people, mash them all together, and create a sort of typical brain map. But we're all different, right? Our brains are too. This new research is all about moving away from that average idea and really focusing on what makes your brain wiring special. It is called precision functional mapping, or PFM. The big question this paper tackles is how we can actually do this person-by-person brain mapping reliably, especially when it comes to things like studying how kids' brains develop or helping people with brain conditions. You see, when you look at brains one by one, things get messy. Imagine trying to do this with limited data, like short MRI scans, or when you are not sure if you are comparing the exact same brain parts across different people. It's like trying to understand the whole library by only reading a few pages from each book. The researchers here are saying that just having a place online where people can share their brain mapping tools like a digital toolbox isn't quite enough. What we really need is something more active, a system that guides researchers on how to make their brain mapping methods better based on actual evidence. They're proposing a kind of central hub, a benchmarking registry that works with existing big science projects and uses standard ways of organizing brain data like something called BIDs. So, what does this benchmarking registry actually do? Well, it sets specific goals and ways to measure if a brain mapping method is working well. Let's break down two big problems they want to solve. The first is called data sparsity. This basically means having not enough good data, like from those short MRI scans I mentioned. When you don't have enough data, the specific network patterns in someone's brain can get lost. Right now, scientists use tricks to fill in the gaps in this missing data, but they're not totally sure which tricks are best or if they're creating something that looks real but isn't. The registry would help by measuring how much information is lost when you go from a long scan to a short scan. This measurement, the stability gap, would then become a target. Researchers would have to prove that their data-filling methods can actually close this gap without messing things up. It's like saying, okay, we lost this much detail. Now show us how you can get it back without faking it. The second big problem is what they call the correspondence problem. This is a fancy way of asking, are we really comparing apples to apples when we look at different people's brains? Our brains are shaped differently and organized differently. Current methods often rely on just the physical shape of the brain to line things up. But this can lead to errors because, for example, a bump on one person's brain might be in a different functional spot than a bump on someone else's. To fix this, the researchers say we need to go beyond just looking at physical shape. We need to use multiple types of information, like a combination of how the brain is built and how it works functionally. To make these comparisons, the benchmarking registry would evaluate methods by how well they preserve what they call neural endophenotypes. Think of these as the fundamental underlying brain features that are important for function. So instead of just aligning based on bumps, we'd be aligning based on shared fundamental brain wiring patterns. By having this central registry where different methods are tested against these clear criteria, researchers would get instant feedback. They'd know exactly which approaches are best at handling limited data and which are best at making sure brain comparisons are meaningful. This registry would connect with massive brain data archives like OpenNeuro and operate on platforms like eBrains, making it easy for everyone to use and contribute. And it would insist on using those standardized data formats everyone agrees on, like BIDs. But here is where it gets even more interesting. High-fidelity brain maps are only half the picture. To truly understand someone's brain health or cognitive abilities, we also need to understand their behavior and how it connects to their uniquely mapped brain. The paper argues that current methods often treat people as if they're all the same when looking at how brain issues lead to symptoms. This isn't always true. How your brain translates into, say, feeling anxious can be hugely influenced by your life experiences, your environment, and your social situation. So they're pushing for heterogeneous association models, ways of looking at brain behavior links that acknowledge this individual variation. They also want idiographic behavioral phenotyping. Idiographic just means looking at the unique characteristics of a single person rather than just typical group patterns. Imagine this whole system, your super detailed brain map, a sophisticated model that understands how your specific brain activity relates to your specific behaviors and experiences, and a detailed profile of your unique life story. Putting all these pieces together, they believe, will create a complete precision pipeline for understanding brain. This is a really exciting vision. The current approach of just sharing algorithms is like giving everyone a bunch of ingredients but no recipe or no oven. This proposed framework is like building a whole professional kitchen with clear instructions and quality control by actively guiding method development through rigorous, evidence-based benchmarking. They can tackle those tricky data sparsity and correspondence problems. Now, for my take on this, I think this paper is spot on. The idea of moving from broad averages to highly personalized brain maps is where neuroscience is headed, and the challenges they highlight are very real. The proposed Metascientific framework, with its focus on active guidance and targeted evaluation, feels like a logical and necessary step. It shifts the conversation from here is a tool to here is how we make the best tools together. The emphasis on empirically guided development, using things like the stability gap and preserving neural endophenotypes, is crucial. It's about creating measurable goals that force developers to confront and solve the hardest problems, rather than just hoping for the best. And the integration with existing open science tools is smart, leveraging what is already out there instead of reinventing the wheel. The extension to include personalized behavioral modeling and idiographic phenotyping is also a significant strength. A perfect brain map is only useful if we can connect it meaningfully to how people actually live and experience the world. The acknowledgement that behavior relationships are diverse and influenced by external factors is a vital insight that could really improve clinical understanding and prediction. Of course, no study is perfect. One limitation that comes to mind is the sheer complexity of building and maintaining such a comprehensive benchmarking registry. It will require significant community buy-in, standardized data collection protocols across many institutions, and robust computational infrastructure. Also, defining and measuring neural endophenotypes precisely could be an ongoing challenge within itself. Looking ahead, the next steps would be for the community to start building out this benchmarking registry. Perhaps pilot projects that focus on one specific aspect, like data sparsity, could be a good start. Developing standardized ways to report on these evaluation criteria would be key. Ultimately, this research points towards a future where neuroimaging can be truly personalized, leading to better diagnosis, more targeted treatments, and a deeper understanding of what makes each of our minds unique. What do you guys think about the idea of a central brain mapping checkup system? Let me know in the comments below. If you found this dive into personalized brains interesting, make sure to hit that like button, subscribe to RUBIN'S Mind Lab for more science breakdowns, and ring that notification bell so you don't miss our next video. Thanks for watching, and I'll see you in the next one.